Every human face tells a story. Lines, angles, proportions. A lifetime of lived experience compressed into essentially geometry. What you're watching now is my face, being built line by line, not born, but printed. And in this episode of Next Tech, we'll be exploring a world where anything can be replicated and what it means to make something. "3D printing isn't new. The concept goes back to the 1980s, but for decades it lived in the realm of industrial prototyping, expensive machinery, and specialized labs. What's changed is everything else: the cost, the precision, materials, and crucially, the imagination of the people using it. At its core, 3D printing begins not with plastic or metal, but with data. A set of blueprints telling a machine where to put material and where to leave it out. It's manufacturing stripped back to its most fundamental level. Hollywood understood the idea long before most manufacturers did.
How close are you guys?
We're just printing now.
That scene from Mission Impossible feels like science fiction. In 2026, it's closer to a Tuesday afternoon at a good fabrication center. Which is exactly why we're here at Plus 90 3D Digital, one of Turkey's most ambitious players in the additive manufacturing space. And before we start talking technology, it's time to get scanned.
I'm trying to stand really still, but it's a little harder than it actually sounds. But these fine gentlemen are scanning me, every angle of my head, hoping to turn something very human into something very digital.
What Ümit is doing isn't just taking a photograph. A camera captures light. A scanner captures structure. It captures depth, dimension, and the precise contour of a surface in a three-dimensional space. Every ridge of the ear, every angle of the jaw translated into a point cloud of raw data.
Thanks to the scan we just performed, as you can see now, we're able to capture all the details. First, from here, you can see how the scan defines the subject using a heat map, showing which areas are captured with what level of quality. What you're seeing here is the raw data. After that, in its textured form, we can capture all the details. When we zoom in like this, you can see the level of precision. Of course, this can later be processed on a computer to produce a more refined image. What you see on this device is essentially the final output it can display.
Don't know if I want to see a very detailed version of myself here, but looks pretty good.
Most companies in this space do one thing, either scanning or printing. But Plus 90 3D Digital has built itself around a more ambitious idea. They are a full-spectrum digital manufacturing partner. That distinction matters because the real complexity in this industry isn't the scanning or the printing. It's the decisions made in between, knowing which technologies to deploy for which application and in which material. The gap between prototype and a functioning end-use part can be enormous, and bridging that gap requires both mastering physics and economics.
Özgür, when you're looking at a specific application, how do you decide between the different technologies, whether it's FDM, SLA, or metal manufacturing?
There is never really a preference. It's actually matching application requirements to process capabilities. So we start by finding the requirements or defining the requirements, functional requirements of the part. Is there any stress on part, any temperature or chemical constraints? Do we have a mass goal or a cost goal? So once we clear these questions, material options are naturally narrowed down.
Okay. We're in front of the design for additive manufacturing, which is a concept which is fairly new, I'm assuming. Can you give me a real-life example where design for additive manufacturing has made a product better, cheaper, more attractive for the consumer?
Actually, there's this project we did with an automotive company working on electric vehicles. And their goal was to extend the range of the car by reducing weight. So they approached us to redesign a seat for additive manufacturing. The original part here consists of around 45 traditional manufacturing parts.
Okay.
But we redesigned it. We applied part consolidation and topology optimization and reduced the number of parts to just 4 pieces.
4 pieces.
And also we achieved 35% mass reduction.
That's no iteration, it's almost reinvention, and it points to something larger about where this technology is heading. Because companies doing most of the interesting work right now aren't printing parts as a replacement for traditional manufacturing. They're rethinking what a part should look like in the first place, unconstrained by limits of molds, tooling, or machining.
Art 93 boyutlu dijital fabrika olarak
At Plus 90 3D Digital Factory, we guide our customers from the initial idea stage all the way to the end-use product. The defining feature of this digital factory is our ability to integrate multiple technologies rather than focusing on just one. For instance, you can combine additive manufacturing with traditional methods, or use additive manufacturing to create complex internal cores for parts produced traditionally. To give you an example, a traditional mold might take 12 weeks to produce. However, by using additive manufacturing to create the mold core, we can combine these technologies to deliver a finished mold in just 2 to 3 weeks. The real breakthrough is leveraging the inherent strengths of both additive and traditional manufacturing. When these two worlds meet, we produce parts that are superior in speed, quality, and cost effectiveness. This versatility is what distinguishes us from our competitors.
But you're moving from prototyping to real production. For companies who want to choose additive manufacturing, where's the tipping point? I mean, how do you inject that sense of trust?
That trust is built on the systems and certifications we use. We're Stratasys' partner in Turkey, and the materials we use are fully approved and certified. For example, the FDM systems you see behind me utilize specialized aerospace-grade materials like Altem 1010CG and Altem 9085. Furthermore, our facility is certified by the Aerospace Quality System and the Presidency of Defense Industries. This gives us the authority to provide parts for high-stakes aviation use.
One of Turkey's strategies is trying to establish itself as a regional manufacturing hub. Tell me where you feel 3D manufacturing or digital manufacturing fits into this general scheme.
bugün eklemeli imalat
Currently, additive manufacturing is already being used for end-use parts within the defense industry. While we're still working toward high-volume mass production, the future looks incredibly promising. In 10 to 15 years, when these technologies are fully integrated into a single machine, we will see a total transformation of end-use production.